Hello. I think I'll start now, but we don't have a lot of people today, anyways. So it did not affect that much. So let us see. Let me see the video once. Is it started to stream or not? So then we can start. So okay, the video is okay. Okay, so I'll just share this link. So this is the YouTube link. So I saw that my video and all is streaming properly. Last time there was an issue with my video, so if somebody can check it out, check and see if my video is really reaching out at YouTube, it would be useful, and then we can start. And this is a drive link, or is it? This is not actually okay. But I had shared the drive link with you. I'll just do that again. Anyways, so I think.
So the drive PDF is also there in the video now in the description box.
Okay. So that is the video link is enough. So that's enough. Okay. Thank you for reminding me. I have added the link, so it's okay.
Yeah, I saw it in the first week's video. So yes.
Yeah. It's in every video.
Okay.
So let's start. So last time I left you. So if the YouTube is streaming correctly, right? So we'll start now. Then. So if anybody could confirm if it is if the YouTube link is working and my video is working properly. So no one seems to. Okay, I'll see it myself then what to do. Okay, so why do you have, like, the first class we had so many students, today it's down to 9. Okay, let's see. Yeah, it's seeming to work. That's good. Okay, let's start. So it's recording is happening, streaming is also happening. So if I have it in here, yeah. So 3 things. So the question that I left you with was this question, where x is any integer and n's are some numbers. So n is an integer here. So we told you how do you find this limit. So I told you would have to use the sandwich theorem in this question. So how do you think we'll have to do this? I gave a hint. So what is this function? This function is the nearest or the smallest integer lesser than x. So for example, 1.5 would be mapped to 1. To minus 2.5 would be mapped to minus 3, right? So
So the bracket sign which is there means x in which the x is. So that is actually represented for smallest integer function.
yes, so it's this bracket sign you're saying.
Yes, sir.
So in this case, it is represented for the lowest number, smallest integer lesser than the x function. So that is the sign for the function. Does that answer your question?
Oh yes, sir. But if it is a greatest integer function, so the bracket
will be on the top.
Okay.
In mathematics, old books generally write it this way, but nowadays is due to the increasing use of computer science notation, people are using both these notations. So this function was a smallest integer less than x function previously, also known as the box function. But now it has people use this ceil and floor function separately.
Okay, sir. Thank you.
Just for that, I'm just writing this notation. So how will the graph look? We had seen last time, right? So from in this case, so for example, from 0 to 1, what will be the value? This is 1. What will be the value of this is
0?
Yes, so 0 to 1, it's 0 point something, so 0 is the value. From 1 to 2, it will be 1, right?
Yes, sir.
So these steps will continue this way. And so on. So from -1 to in -1 you will have -1. That's it. That's the function. So how can you use a sandwich theorem here? Can anyone tell me? You can. This is not easy to compute, right? So but if we can convert it to a sum of series, for example x plus 2x plus 3x and so on in x, so now this becomes a sum of I, right, from I equal to 1 to n. Now we can compute. So you have to do something like this. So how do you think we can do that? So do you agree that this is true? Would be less than or would be greater than this? And would you agree that this is true?
Yes, sir.
Because at max you can have 1.999 and that would be mapped to or some 9999 till infinite. So that will be mapped to some 0.9999. But your more box function would give you 1, right? So that will be greater than 0.9999, right?
Sir, so for the x means x minus 1 is less than equal to the box of x. Is it not equal to less than x only? Why?
Yeah, it is less than x. So I just, this is just using this condition. So if it is less than x, equal to is also true, right? So it's a weak, equal to is a weaker, less than equal to is true, then it's not, the other way is not correct, right? So,
right.
But this is, if the other thing is true, this is also correct. That's what my idea is. You can also use this. You will also get the same answer, but it doesn't change anything. But to use the sandwich theorem, we generally use a greater less than equal to, right? So if a function x is less than y, it is also less than equal to y, right?
Yeah.
Equal to condition does not hold, but I for my safety I am adding more points, so that may not exist. For equal to, it can be an empty set.
Okay.
So for this I am using this, but greater than x is correct, right? So this will always map to lower number. This will, if it is 1, it will be 1. If it is greater than 1 to 1.99, so it will map to 1, right?
Yes.
This is 2, 1.99, 1.2 will also map to 1 and so on. So box function, x is always greater than its box function, right?
Yes.
So that's the idea. So let's put it into full screen, right? Yes. Now it's very simple now. So for example, if you have nx, what will it be? It's less than nx minus 1. Well, let's put kx here. Just putting kx instead of x. Put the value of, or if you are having some issues with it, you can think this is y. Hence x is equal to ky. Did you understand what replacement did I do? For k is any integer or natural number. Is that okay?
Yes, sir.
Is this step correct? Is anyone having any issue with this step? If you have, you just ask me. I just replace the x as kx. We can do that, right? It's any function. So if I have mod of y, I put y's value to be kx. That's the idea. So let me rewrite. So for the sake of confusion, solving the confusion is y. Is that okay? So then I put y is equal to kx. That will help. That would be a valid what is it? A valid assignment operation. I don't think that's not a problem. So we can go ahead. So let's do the left hand limit and the right hand limit separately. So the right hand limit. So the right hand limit. So I had told you. So this is your okay. So this is your f of x. This is your h of x, and say this is your g of x. So what did I tell you? If two functions have the same limit, the upper function and the lower function, and if you have a sandwich theorem, which is a function that is sandwiched between them, the middle function will also have the same limit, right? This is the idea. So let's find. So this, can anyone tell me what is limit of hx x tends to infinity or n tends to infinity? This is one liner. X plus limit n tends to infinity x plus 2x plus dot 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 nx by n square. What is this? Go ahead and tell me. This is very simple. So x into sum over I equal to 1 to n I, right? By n square. Limit n tends to infinity. Is there any doubt regarding this? Every mod x function I have replaced by x. Did you understand? Every box of x I have replaced by x, which is greater than box of x. So this is nothing but, so I see n into n plus 1 by 2 into x by n square. So this is nothing but x by 2 at limit n tends to infinity. Why is it n by 2? So if I divide 1n, 1n cancels. So it is x by 2 pi into n plus 1 by n. So n plus 1 by n at limit n tends to infinity, what is it? It is 1, right? Both are same. So very large number, you add 1 to it and divide by the same number, you get the same, you get a very close number to 1, 1.00 something. Did you get why it's 1?
So can you explain from the part where you took that sum?
Okay. So you're saying this part, right?
Yes, sir.
So is this part clear, this step?
Yes, sir.
This step I have replaced every x by box of x by x, right?
Yes.
So I took x common. Everyone has an x, right?
Okay, yes.
And that is a sum from 1 to n now? 1 plus 2 plus 3 plus 4 plus 5.
Okay.
Right?
Okay, sir.
So that is what? A summation of 1 to n. And I is 1 into n plus 1 by 2, right?
Yes, sir.
So that's what I have done. So this is your x by 2 is the limit. Similarly, on the left hand side, you will have x plus 2x. Go on, what will it be? 3x plus nx minus, well, what will it be? I am using this kx minus 1. What will it be? So if I replace every box of x by minus n, right? Very good. You said n, right?
Yes, sir.
Yes. So because all these n numbers have minus 1, so this will be for your g of x, this will be replaced by x minus 1, x minus 2 and x minus 2x minus 2, 2x minus 1 and so on, and x minus 1. Is it clear for this function? So that's what I'm writing, by n square. So this is also very simple. So you can calculate this. Limit n tends to infinity. So you'll have n into n plus 1 by 2x minus n by n square. This is also the same answer, right? X by 2. because this x by 2 minus 1 by n, so 1 by n goes to 0, right?
Yes, sir.
So both your left and right hand function is giving you x by 2. So what would be the middle function giving you?
X by 2.
By sandwich theorem. So this is a simple example to use sandwich theorem. So before we go into the epsilon delta formulation, can anyone tell me if they have any doubt regarding the left side of it? So left side of it, I just replaced x with x minus 1, that's it. X to x minus 1, and then I just followed. So sum of all minus 1s from 1 to n is n. So you get x minus, so this goes to 0. So this is the idea. So this sandwich theorem problem is solved. So let's go to understanding one-sided limits. Last time I told you that limit does not exist if left hand limit is not equal to the right hand limit, right? So let us see, how do you define one-sided limit? So in many problems in computer science, in physics and so on, you would be requiring the function to be continuous at one side, or to have a limit on one side. So how can you say if a function has a limit L on a particular side? Are you able to understand what I mean? So let's look.
Not exactly, sir.
Yeah, I'll look at this. Let us look at this diagram. So left hand limits and right hand limits respectively. So I'll draw this. It will be very simple. I'll just give you this intuition. It will be easy to understand. So you say you have this function and you have this function. So this, at this point, you have a discontinuity of jump, right? From right side and left side, both numbers are saying different things, right? So this is C. Is at limit, say this is C. This is your f C minus, and this is your f C plus, right? This is the idea. So what does this mean? So I mean, if I go from left to right, I would get this as the limit. This is the intuition. I'll give you the mathematical way to do it also. But if I go from right to left, I will get f of C plus as the limit.
Yes.
So I would see, come down this way and see where the sequence is converging. Where am I going at as my delta goes very close to C? We have done that delta epsilon formulation, right? So we'll do that again. So for remind you, so it will be very simple to understand. Similarly, as your delta goes to 0, to which number are you converging? So as you go from left to the C, so as you go from C minus delta, so I'm doing here left hand limits. Let's do for left hand limits only. So this is your C minus delta to C, right? So x between C minus delta to C, both are not included as we had discussed before. So we are going very close to it. So if a limit is L, what will we expect? That there is no jump from that number, right? As delta goes to 0, the jump in the function value would also go to 0. That's the epsilon delta intuition, right? So for example, if this is the limit, this is your f of C minus delta. So what does it say? For all numbers, so this is your L minus epsilon. For all numbers of x between C and C minus epsilon, your function of x should not deviate from the limit more than epsilon, right? I think you will be able to understand. Now again, people are getting silent with this formulation. So is this diagram clear? So I'm saying this. Say this is the limit, and this is your C minus delta point, where the function is C minus delta. My claim is for all numbers in between this, your limit value should not be further from in your function value should not be further from the limit value more than epsilon. Let's draw it again. When you'll say yes, I will stop there. So for example, I'll just show the left hand limit, right hand limit would be very simple. See, math is very simple to formulate. So I'll give you one line, it will be easy to formulate, but the intuition will give you you'll be able to formulate the maths yourself once you have the intuition. This is C. See, I'll take for diagram perspective, I'll just take a larger delta. So this delta is, so this is x would belong to C minus delta to C. Is this step clear?
Yes, sir.
Next step is, so these are the function values that the function takes between C minus delta to C. Let's denote it by the left hand of C, right? So we did or maybe minus like this. The left hand delta of C, left hand neighborhood of C. We define it this way. So this,
yes, sir.
This function is your left hand neighborhood of C. I hope now everybody is getting it. This intuition will help you. Now say your limit is somewhere here. What do I mean now? My idea is, for all values in between this to this, your limit must not deviate more than epsilon. Say, I'll give you an example. So this is your epsilon, okay? Right?
Yes, sir.
And this is your x2, and this is your limit L, and this is your limit x2. So is L2 minus x less than epsilon? It is, right?
Yes.
So
yes, sir.
x2 is much larger, x2 L2 minus x is smaller. This is the idea. So whatever limit you choose, so epsilon delta has always, you choose a limit or you guess a limit. So often what you will have to do is, mathematicians would first do a limit algebraically, and if there are any confusion regarding uncertainties, regarding jump discontinuities, limit does not exist, they would like mathematically prove that it does not exist and so on. So this is a way to more or less prove that limit does not exist and so on. It is not a way to find limits, but it's a very important intuition, that's to say. Let's look at this. Now this picture gives you a clear idea that for all x between C minus delta to C, so first point is, I will select an epsilon greater than 0. That is my selection. So next is, you can choose a delta such that for all values of x between C minus delta to C, what is true? F of x minus the limit is less than delta, right? Is this
Yes.
okay?
Yes, sir.
This is the idea. Now it is, so whatever I wrote in the diagram, you can translate to maths by this. So the maths is a game. So you choose an epsilon, you say, I will choose a delta according, I will give you an epsilon, say, because it is for all epsilon greater than 0. So I will give you an epsilon. Now your task is to choose a delta. So this theorem says that if the limit is L, you will be able to find a delta. If limit is L, this intuition if you get, you will never forget anything about epsilon delta. If limit is L and I give you an epsilon, you will always be able to find a delta. This is the idea. So you would evidently be able to find a delta, right? So if your epsilon is this, you would essentially take this as your delta. That's the idea. So how will you be able to find your delta? Let's do some examples, we'll understand. Similarly, your right hand limit, so that's what I've defined. See, so for your notes purposes, I've written it here. Left hand limit is L if and only if for every epsilon greater than 0 there exists a delta such that the value of the function does not shift from the limit value by more than epsilon. That's exactly what it is. Similarly, right hand limit. Now somebody, if you have understood, how will you formulate? Let's formulate the right hand limits. Give me the epsilon delta formulation of the right hand limit. This is C. How will I formulate this? I already told you need to come from the right to the left. That's why it's called a right hand limit at a point C.
So the delta will be C and C plus delta.
Very good. So C will be delta. So you will get this region. So C to C plus delta, and that delta you will get only after you're given an epsilon. This epsilon, right? And a limit L, and then you choose a limit such that these function values are bounded between L plus epsilon. So you will have fx minus L would be less than epsilon for all x between C to C plus delta. Who pointed it out is correct. Does anyone else have a problem with it? So if this is the limit, say, and you say that this is the epsilon value, you can always choose a delta so that this is true between for all those values of x. So the idea to read is you take x and delta very, very small to close to one another, you will always converge to the same point. This is the way to read it. Way to read C comma delta or epsilon comma delta tends to 0, your fx tends to L, right? Is that correct or not correct? So around the neighborhood of the function, when you have epsilon and delta tending to 0, you would have this tending to
the limit,
and x is between C to C plus delta, which means where limit of x tends to C, f of x plus is equal to L. These are all jargon that you need not worry about. Similarly, I have written this over here. Let's do a question, you will understand. Right? Let's take up this question and let's solve it. Did you see which question I'm talking about? Just a second. Yeah. This question, right? I'm going to do this question now. So we'll see, you have to show that the limit of fx is 0 using epsilon delta. How will you show this? So what I meant is, can anyone tell me, does limit exist for this function at C? Does limit exist for this function at C? Graphically, whatever I've drawn.
Yes.
Does it? So limit,
Sir.
It doesn't. Why does it not? Because your C limit x tends to C minus f of x is not equal to limit x tends to C plus f of x, right? It is very clear from this picture.
Yes, sir.
This is the right hand one, this is the left hand one. They are not equal. So if they are not equal, there is a jump. So at a point, there is no limit. At a point, exactly, we are not going to discontinuity now. It's a jump discontinuity, whatever discontinuity. Since there is a jump, what happens is, for limit to exist, your function must converge from both sides. Limit exists when function converges from both sides. Did you understand? So does this function converge to the same point, to be exact, to same point from both sides? Does this function converge to the same point from both sides? They converge to different points, so that limit does not exist, right? Okay, go ahead, Tanushree.
So nothing.
Okay, great. Let's do this question. Solution for question 2. So first let us plot this graph. Tell me, how will this graph look? I have already given you two previous lectures. This is the third lecture we are doing. Third tutorial session on this. How will it look? How does root x look? Y is equal to root x. This is like this, right?
Yes, sir.
So how will y equal to root x minus 1 look?
It will start from the point minus 1.
1. So you shift from 1. So if you minus 1, if it starts from minus 1, so minus 1 is minus 2, right?
Okay.
So this is the new center. New center is 1. When you have x minus a is your new center. X
Okay.
plus a means x minus of minus a. So minus a becomes your new center. And understanding why does that happen? See, I'll give you the example. Understanding. See, x minus 1. For at what value does this function become? What values does it? Yeah, the right shift is right, Mr. Pandey. See this. Look at this. This x minus 1 at x is equal to 1 is 0, right? So if you
Yes.
if you take this as y, so at x is equal to 1, this is becoming 0. So for all values of x equal to 1, it will be this way, right? So just shift it. So for example, root x, or if you want to get root 2, what will be the value of what value of x do you need to put here? What will you put in x? X is equal to
Minus 1.
no x minus
to 3, sir.
x is equal to 3, right? 3 minus 1 is 2.
Okay, sir.
So see, so what is actually happening is just shifting it towards the right. So whatever happened at 2 previously is happening at 3. Whatever happened at 1 previously is happening at 2. Similarly, what happened at 0 will happen at 1. That's why there is a right shift when you have minus. Similarly, 1 minus x is this, right? It's a line with intercept 1 and negative slope. Is there any doubt regarding this function?
No, sir.
No, sir.
So, according to you, does limit exist or does not exist?
Exist.
Yes, because from both sides it's going to 0. So your limit x tends to 0, 1 minus, I'll also do it by, this is the algebraically we're doing, 1 minus x is 0. Similarly, limit x tends to 1 plus root over of 1 x minus 1 is also 0, right?
Yes, sir.
From both sides it's becoming 0. So since it is 0 from both sides, we can take the guess of limit equal to 0. And now let us solve this question. So let's do our favorite thing. So for the left hand limit, let's give you an epsilon greater than 0. This can be any epsilon. So what will happen? What will be our next step? We know L is equal to 0 as the guess, right?
Yes.
So what did I tell you? So we'll have to find a delta such that x between c minus delta to c, fx minus L is less than epsilon. Is that right?
Yes.
Yes, sir.
Let's do it now. So for the left hand limit, limit is L is 0, so it's 1 minus x only, right? So because this is always positive for x less than 1, so there is no negative part to it. For x less than 1 minus x is always positive, right? So you can see from the graph itself.
Yes, sir.
Yes, sir.
So you will get x is greater than 1 minus epsilon, right?
Yes.
Now, and by definition I am using this point as we discussed in the first class. This is true. So can anyone tell me what is the delta now? X belongs to, if we take 1 minus epsilon to 1, so your delta is equal to epsilon. If you take it,
Yes.
it will work. Very good. That's the idea. So this equation is going to give you the idea of what you need to take, right? You can always choose an epsilon by 2 also. That will also work, right? Just for safety. This is true for all values of epsilon between 1 minus epsilon, right? So if you epsilon by 2 is also less than epsilon, always, right? So you just need to choose one delta is enough, right? Did you get the catch? So sometimes what will happen is, if this has to hold, this has to hold. So you can choose epsilon delta is equal to epsilon. You can also choose, but in the case of epsilon, what will happen, this left hand limit may be, it's an open limit, right? So open point. So in that case you may choose epsilon by 2, which will always be less than epsilon, right? So anyways, these are technicalities you don't need to think about. So I got this equation. I'll just draw this for you. So this is 1 minus epsilon. So I'm taking this limit. So if I choose a delta somewhere here, this is also true, right? This holds, the equation also holds for this 1 minus epsilon by 2 to 1. It holds or not holds?
Sir, I have a doubt.
Yes, go ahead.
Sir, when we choose a delta, should it always be less than epsilon?
Less than epsilon, I don't understand epsilon. So you will have to get a limit, right? So this is you will have to match this with this. X belonging to C minus 1 minus delta to 1. Right?
Yes, sir.
So here both delta and epsilon will work.
Okay.
Isn't it? So because these two have to match.
Yes, I understood when we took delta as epsilon, but
Yes.
when you told epsilon by 2, I got a slight confusion.
No, if you take epsilon by 2 also, what my point is, you will have x between these two, right? So these are subset of the superset.
Oh, okay.
So if it is true for 1 minus epsilon to 1, epsilon 1 minus epsilon by n to 1 is also true, right? So
yes, sir.
delta
Yeah.
can be any like that. I'm just telling you, in case you cannot directly get a closed form, you may have to maneuver little bit, do a little bit of hand crafting with the things. That's why I'm telling this thing.
Okay, sir. Thank you.
I hope it is clear now. Similarly, right hand limit, somebody, what should I write? I will not write the steps. What should be the values that I should write?
Then it belongs to C comma C plus delta.
Yes, x greater than 1, right? So x between
Yes, sir.
1 and 1 plus delta.
1 and 1 plus delta.
For that, f of x will be, tell me, will be less than epsilon. Right?
Yes, sir.
Yes.
So here it is x minus 1 less than epsilon, because it's always positive number. So there is nothing to worry about. So this is epsilon square, x minus 1. So x is less than 1 minus epsilon square. So if you compare these two, again 1 to 1 minus epsilon 1 plus epsilon square, and x belongs to 1 to 1 comma 1 plus delta, you see delta is equal to epsilon square, right?
Yes, sir.
So both left hand limit, you're getting a left hand limit is equal to right hand limit is equal to 0. So limit exists. I hope this is extremely clear now. So epsilon delta will be moving away from epsilon delta from the next week. We'll go to continuity and all these things from week 4. So I hope this will give you a proper understanding. Now, okay, go ahead. Somebody had a question. Somebody had a question?
No, sir.
Okay. So we'll also do a limit at infinity using some examples. So see, infinity does not belong to the real numbers, right? So don't look at the definition I've written on the right. Look at the diagram that I will on the left. Look at the diagram on the right. So infinity is not a part of the real number line. But we want to see as the numbers go very, very large, it explodes. Where does a function go to? So can anyone tell me our limit, a minus infinity, which limit will you only have?
Zero, less than zero limits.
My question is, at minus infinity, as say x tends to minus infinity, which side limit will you consider?
So the left hand side.
I will recommend you to draw this diagram in your copy and see if it is really left hand side or right hand side. So this is, say, your graph, right? And this is x tends to minus infinity. So you're coming from the right to the left, right? So it's only right hand limit will be considered, right?
Yes, sir.
There is nothing after infinity. Is there anything after infinity? Infinity is an abstract concept. You can never reach infinity. So if infinity plus delta does not make any sense, right?
Yes.
But but numbers less than infinity do make sense. There is nothing called greater than infinity. Similarly, when you have functions going to the right hand side, right limit, you go from the left to the right, so you have left hand limit, right?
Yes, sir.
So let's see can you use the epsilon delta formulation here? See, because your f of x minus L less than epsilon, how will you use this to get x values to infinity? I mean to say, how will you formalize x tends to infinity, fx is equal to L using epsilon delta? There is an issue, right? There's a clear issue, because you cannot even do infinity minus delta to infinity. There's no way you can do that, right? There's nothing called infinity. So here we have to take a number, a large number, right? We can't take infinity as the point. We'll have to fix a number, say m. Is this understanding clear? Is this need to take an m clear? Can we do infinity minus delta? Infinity is not a real number, so it does not make sense to subtract a real number from a non-real number, right?
Yes.
So we will subtract real numbers only from real numbers. So m is a real number that is close to infinity, say.
Okay.
So from that I can subtract delta, right? It's a finite number.
Yes.
This is how you do logic. Mathematics is all about logic. See, in school days you did not need to do this. You could just do the division and say this is working. But once you go to graduate studies and so on, undergrad studies, you will have to understand how to formalize stuff. See, so what happens is, for values of m, say I have m, I choose an m like this. So I can choose this as the region, right? And say your limit is bounded by some delta. So how will I do that? Say for every m greater than 0, right, there will exist a delta greater than 0 such that f of x minus the limit is less than epsilon for all values of x between m minus delta to m. Is this clear? So let's see, we have written it down here as well. Or you can also write it. So what I did here is, instead of writing m minus delta to delta, you can also do something like this. This is, you will again have to tend limit to infinity. So what you can do, say if there is a threshold for m greater than 0, so you can just write m greater than m, right? Since your value is converging, you don't need to just see in the vicinity, right? So m minus delta to your m, right? This is my idea. But this m can go to infinity, right? Limit of m can go to infinity. This is what I mean. So you see, say value of m is here, So for all the values to the right, the function must also converge to the same point if the function is converging at infinity. If this is your convergence point, say you have a threshold m, so I'll draw it again. So I wanted to show why is this if delta not required here. So this delta is not required because from m onwards, from m to infinity, all values converge to L, C, Y. So this is your function. So I have a value m like this. So if my value, if I say I am given an m like this, and after m at infinity, infinity is greater than m, right?
Yes.
By our convention. So at if at m 2m plus delta and so on, the function converges. It should converge for all values to m greater than m plus delta also, because I can shift m from m as well and select your delta accordingly. So I'll give you the diagram here. See, so you will select an m like this. Once you select an m, you will get a, say, limit idea L. Next you will have an epsilon like this. So given that limit L, deciding your epsilon, you may be able to say what is the value of m you choose. So for example, for all the values of m greater than 0, there exists a delta greater than 0 such that your f of x minus the limit is less than your epsilon for all x greater than m. Instead of writing x belonging to and not writing x belonging to x to m plus delta, because m is our imaginary point, right? M is not, we are what are we trying to find? We are trying to find limit x tends to infinity. There is no m here, right? So taking m plus delta does not make sense. You can always go above that. So if it has to exist at infinity, it has to exist at all numbers greater than m. Otherwise, it's not converging to at infinity, right? Say for example, you have something, if it does not converge, it goes upwards. Does it converge at infinity? So for infinity, there is a slight change in the definition. That's what I meant. So there were people who understood the previous definition, but I think they are not understanding this one. So if I choose I'll give you an m, is my idea. So I'm saying you will be able to give me a delta, or say give me a epsilon, whatever you want to. So here delta is not making any sense, right? So delta also you don't require. Give me an epsilon. There exists an epsilon. Or should I reformulate this? Let's do it other way. Say your limit is L and I give you an epsilon this. This is your epsilon. After m, all values are not infinity. That's what I meant. So let's do it. Let me draw it again. Let us take this drawing first and then I'll draw it. So here we are trying, last day I was telling there is a 1-1 definition. So this is creating a problem. Yes, see, we're not being able to formalize using first selecting m and then selecting epsilon. So let's select an epsilon first. What is the range of error that you can accept? So let's select that epsilon first. Say I have a function like this. I'll do the question also, it will be clear then. See, I select, say this is your limit at infinity, right? I select this as the limit at infinity. Yes. So Ankush, if you don't follow, you just tell me. And I give you a delta such that, or again I'm telling delta, sorry for that. So I give you an epsilon. like this. I would want to select an m, say this, such that for all values of x greater than m, so I selected this value, say, since this is epsilon, and say this is your m. Is it for all values of m greater than this, it is inside the L minus epsilon? Did you
Yes.
So if it is converging to this point limit L, so whatever epsilon I choose, this is say your epsilon, there will be a m value after which all the values will be inside your delta for that particular limit. So that's the way you will understand. So how will I define? Is it clear, Ankush? So it will be after that value of m, all the values will be. So instead of drawing this limit L on the top, I think it will be easy for you to understand if I draw it down. Let's do it. So say this is your value of limit L. This is your limit L, and this is your epsilon. So it's converging to this value, and this is your limit L plus epsilon. Do you sense this, that at this point all values of m greater than x greater than this is this L, this f of x, so this is your, say, f of x prime minus L is less than epsilon. Do you sense this now? I think now it is very clear, right? I drew the L on the other side, so it's now Ankush, it is cleared for Ankush. Others?
Yes, sir.
I think this diagram you should keep in mind. So this is how you formulate. Like, the intuition is very clear that after a particular point it will converge, but how will you formulate it? So formulate it, you need to have the entire clarity in thought. So clarity in thought helped me to bring out this definition like this. So see, this diagram, so this is your limit L which is converging to, and this is your L plus epsilon. So I will give you an epsilon, so there will always be an m where, say, it converges. So for all values of m, x greater than that value of m, this will be within this epsilon bound. This is the idea. So I give you an epsilon, say for every epsilon greater than 0, I give you this. What will you choose? What will you choose? You will choose, I heard a lot of people, is it related? It's Cauchy sequences are a special case of this. So sequences that would be in random processes and all, so that also relates to this, because your Cauchy sequence would converge to the same point. So this is the same idea. Is that okay? It is actually correct. That is also, any convergence is related to the epsilon theta bound. You are actually the sequence converges to a particular point. Is that okay? That's how I am actually defining this. This is also a sequence, right? So these values are sequences. F of x prime, f of x double prime, and so on. Is this alright, Ankush? This is also converging to L. This is known as a sequence that converges to L. That's great. So what will you choose? Anyone? You can unmute and tell. See, in the chat the problem is the screen becomes smaller, recording becomes a problem. So unmuting would be a better option. So what will you choose? I gave you this epsilon. So what will you choose? Such that what will you choose?
M.
Correct. You will choose an m. See, there exists an m, right? So you will choose an m for all values of m. So in this range, you see all the values of the function are between L and L plus epsilon, right? This is the intuition. Are you seeing that? Amrita, you told you'll choose M, right?
Yes, sir.
So after choosing M, do you see all values after M is actually converging to, is having a lower gap to L than L to L plus epsilon?
Yes, sir. Yes.
After M, everything will have a lower value. So I'll give you a homework. Formulate this for minus infinity. I think you'll be able to do it, right? Don't do it mechanically. Do it like we did. Okay. Say I give you this
Yes,
function and try to formulate this limit. What does it go to as minus infinity? Limit x tends to minus infinity. Try to do it. This is a left hand limit. It's the same thing that you will be doing, right? There's nothing new to this. So just one side I did, one other side would be for all values of x less than m, right? So if I draw this, so there will be some m, all these values of, so you'll have to choose an m, choose m such that for all values less than m this will hold. Then only you will have a left hand limit. In our case, it's going from the right to the left, so you'll have the right hand limit.
So, sir, here m will be less than 0, right?
M can be, yes, m will be less than, no, it doesn't matter. M can be, just a second, m will be less than 0 because x is less than 0, right? X
Yes,
is going
sir,
to
yes.
minus infinity. M is less than 0. Choose m
Okay.
such that, yeah, that is obvious, less than 0. So I've also written the definition somewhere here, so that's not going to be an issue. So at minus infinity I've written it down. So minus infinity will have right hand limits only. So I would urge you to do this. I think it will give you a very good understanding. Let's do one question. It will give you an understanding how to do it. So tell me what is the limit of, let's first guess L. What will be its value? 1 by e to the power of x minus 3 limit x tends to infinity. What will it be?
0.
Correct. Because this goes to infinity, right? E to the power infinity is infinity. It's very
Yes, sir.
So that's the hand wavy way to understand. So 1 by infinity is 0. Any finite number divided by infinity is 0, right? Infinity is not a number. So for infinity I mean any finite number divided by epsilon delta method for all values of m greater than this and so on. That's what I mean. Do you understand what I mean? So infinity you cannot generally divide by, but you're dividing by very, very large numbers. So eventually going to 0. Right? This is how you do it algebraically. You must be knowing this. You have already done this in school days. Right? Do you have any doubt regarding this? Why it is going to 0? We'll see why it is going to do 0. What arbitrary value? What is arbitrary value? What do you mean? I said arbitrary value as in like delta epsilon. M is the value, right? So epsilon will be given to you. Delta you will choose. L is what you will guess. I will tell you. Yeah, can you? Your meaning to how will we solve, right? What is the value of m you are asking, right? Ankush? We'll solve that, but we'll have to guess the limit first. Am I understanding a question correctly? Yeah, let's do it. So this is limit. We take a guess to be 0. It's a very large number. So let's do that then. So e to the power 3 minus x minus 0 less than epsilon is what you will do, right? This is true for, so first is for all epsilon greater than 0. So we'll have to find a m, right? M greater than 0. This is our task. If we can find that, we are done. Let's find it. So e to the power 3 minus x is always positive. Does anybody deny that? Exponentials are always positive, right? This is your exponential graph, e to the power x. So e to the power x. Similarly, e to the power 3 minus x would be, first you would, at 3 you will have this thing, whatever 3, you will have it at 1, and then you will just go like this. Previously, if you do not understand, stop me once I have completed this, so we can draw the graph again, how I did it. See, now what will I do? Take log on both sides. So log of e to the power 3 minus x, log of epsilon, this is 3 minus x, less than log of epsilon. What does it mean? X is greater than 3 minus ln epsilon. Is it okay now? See,
Yes, sir.
this, as somebody was, so m I can choose as 3 minus ln epsilon. Can I choose this as m, right? For all these values of m, it will hold. Now Ankush, tell me, is this what you were asking, or you were asking something else? Steps is, first give an epsilon. See, first step is guess an L. Step 2 would be give me an epsilon. Step 3, I will give you a delta, here m, such that fx minus L is less than epsilon. Now Ankush is not answering, so I guess it's clear, because I asked him a few times. So let's go to the next part. Others, it's clear, I understand. So
Yes, sir.
okay, let's go to the next part. So limits at infinity is okay, but what do we mean by limit equal to infinity? So last time I had told you this has limit equal to infinity. So we had all this definitions of what does it mean by limit, this becoming infinity and so on. So is infinity a number? Is it a real number?
No, sir.
So we face the same problem here, because we cannot, so our limit is if we take limit as a function, yes, sequence divergent, yes, it's a divergent sequence at 0. That is correct. Are you getting the parallels between the sequences, right? So it's a convergent sequence, as the Cauchy sequence you said, a divergent sequence that blows up, and this also is the same thing. It's actually a function. Each point in the function is actually a sequence. If you write down the numbers that the function gives for c plus delta, c plus 2 delta, and so on, it will give you a sequence, and that sequence will converge. Is that, or diverge? Is that all right, Ankush? In this case, it is a divergent sequence. But anyways, for divergent sequence, limits, some mathematicians like to define these divergent sequence equal to infinity in this form. So equal to infinity, so our limit is a function from reals to real union minus infinity and infinity. So this is how sometimes people often define limits to be. So our function may give you limit is equal to infinity, whereas Ankush told when the sequence fx plus delta and so on diverges. Whenever it diverges, it means it is no bound. It can go to wherever it wants. So if it can go wherever it wants, then we have to write a number to it. So we write a cap. We write infinity. Is that all right? I think the intuition is very clear now. Why we want our function, limit function, to exhibit the characteristics such that it can output an infinity as an answer. although infinity is not a real number. It's clear, right? I hope so. Since there's no questions, let's go to the definition. So informally I have defined this as the criterion for limit to be infinity. When both left hand limit at a particular point C and right hand limit is infinity, then you say limit exists at equal to infinity. But as only divergent sequences at infinity, limit does not exist. Why does not exist? Can anyone tell me? So divergent sequences, limit, or you can say it exists as well, so leave that. So we'll not, as C goes to infinity, we can also say it, so for example x square, as limit x tends to infinity, we can also write this as infinity, so it's okay. At infinity also divergent sequences anywhere at any point. So we'll not consider infinities at infinity, those are unbounded numbers. So let's take for when functions blowing up at some intermediate points. At infinity it blows up, you don't have any problem, you can just write infinity because there is no concept of left hand side and right hand side there, right? At infinity or minus infinity, no concept of left or right. Your left hand limit is equal to your limit. Is my idea, did I convey my idea properly? Why are we considering a point that is not equal to infinity? C is not equal to infinity. At infinity you either have the left side or the right side and you consider that to be your limit. So I just write it this way. At infinity, left hand limit is equal to limit. At minus infinity, right hand limit. This is the definition that we are using. There is no hard and fast definition. Just to cover the edge cases, mathematics comes up with formulation so that mathematics looks well within rules. Otherwise mathematics can go haywire at these edge cases. Let's do it. So but at a point at C, say 1 by x, so this blows up, you will agree, at 0, right? This function would be at very close numbers close to 0, this function would blow up to infinity. Similarly at on both sides, this is the graph of 1 by x square. 1 by x is this. So if I take x square, what I told, I will take a reflection about the x-axis. All these things I had already told two times in the last session. So you can see intuition tells you that at infinity both are going to infinity at C tends to 0. So you can from intuition say that your limit is infinity. But let's do it mathematically. Let us first define. How will you define this? So this is your formal definition. Let's look at this. So here you will have a left hand definition and the right hand definition separately, right? So let's say let's do it again. This diagram slide reading is very annoying. People don't understand. So let's take one side. Limits equal to infinity. Here we are only considering the right hand limit, okay, at 0. This is 1 by x square for x greater than 0. Now tell me, how will I come up with this epsilon delta formulation for blowing up? Can anyone tell me? I have already given you 3-4 examples for this. So I want limit C tends to 0 plus f of x is equal to infinity, I want to say, or 1 by x square is infinity. How will I come up with this formulation? How will I do this? How? Using epsilon delta method. So say I will give you an m, or let us say there are 3 things that I need to give you. So let us give you step 1. Step 1, I give you an m. Whenever there is a step that is not clear, you stop me. So m in the y-axis, in the domain, in the range of the function. So for example, I give you m. Okay. Now, say this is m. So this is cut somewhere here. So my idea is I will always be able to select a delta such that between c and c plus delta there exists a delta greater than 0 such that fx minus fx is greater than n. Does this make sense? What did I write?
Yes, sir.
I think this is very clear because we have already understood the epsilon delta formulation. See, step 1, read the steps. And with these steps, you are actually understanding that there is always a epsilon delta formulation. For every m, you will have a delta. So as you go very, very close to 0, m will also grow to very, 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 very large, right? So you can say as delta tends to 0, m tends to infinity, right? So fx tends to infinity. This is how you read it. I think this is the idea. I'll repeat this once. So I give you this m, right? Now, I will always be able to find a delta, right? If the function is diverging such that between 0 and 0 plus delta in our case we are finding limit at 0 plus, the function value is greater than m, right? The function value is for all these values of x between c and c plus delta is greater than m, right?
Yes, sir.
I hope this is clear. Now let us go to the definition. Let us go to the example. So this is the more or less the last of examples that we would be doing with epsilon delta methods. Now we will shift gears to seeing algebraically, because complicated limits won't be easy to deal with epsilon delta. Let's do this. So limit of 1 over x square, how will you do? Any idea how will I do? How to prove that both that the function at x tends to 0 is going to infinity? How will I prove this? What are the steps? Large steps.
So we first fix an m greater than 0.
Correct. But before that also we need to fix something, right? So c minus delta to c plus delta does not make sense when the function is diverging to infinity. Because both sides, if it is infinity, where will you do minus greater than comparison, right? You can't do from between minus c minus delta to c plus delta. Or you can do. Apparently it does look that you can do, but I want to do it on both sides, because if this was 1 by x, then it would have been a divergence sequence. Then you would have a left hand limit as right hand limit as different, right? 1 minus infinity, 1 is infinity. So that's why I want to do it this way. Is it okay?
Yes, sir.
So yeah, so let's do it left hand limit and right hand limit separately. So let's take x greater than 0. For x greater than 0, as you pointed out, Amrita, right? You pointed out.
Yes, sir.
So yeah, so we would choose an m, or say I give you an m for all m greater than 0. When we write I give you an m, I have the control of giving you any m. So I gave you one m, and so it holds for all m. This is the mathematical idea. This game converts to mathematics for all m. So what is our tasks now? Our task is to find a delta, right?
Yes, sir.
Find delta such that, so I have step 1 also was 0, step 0 was limit is equal to 0, that we have guessed, right? F of x minus 0 is less than or is greater than epsilon, is greater than m. That's what, or there is no mod here. It's growing like this. So f of x is greater than m, right? We need to find epsilon in this manner. Let's do it. So it is x square 1 by x square m, right? So 1 by x square would be less than 1 over m. So x would be, so I only take, this is for x greater than 0, so 1 by m would be positive only, right? I don't think there's a problem regarding that. So what is your delta here? Delta is equal to root 1 by m. Is it okay?
Yes, sir.
I just did what I told, right? So I just wrote fx greater than m. I replaced f of x is 1 by x and just change side. I did cross multiplication and found delta. So there is a delta, right? So left hand limit. So this is your right hand limit or left hand limit. Right hand limit for x greater than 0 is equal to 0. Similarly, tell me the steps for the left hand limit. I want someone else to tell me the steps for the left hand limit. If somebody can. What would be the first step? Guess L, I'm telling is 0. Next step is what? Next step is M.
M less than 0.
See, M will always be greater than 0 in our case. If it is, we are saying limit is going to infinity. We are saying limit is going to infinity, right? If it was minus infinity, then you would have said it is going to m is less than 0, because then it is diverging to minus infinity. Did you understand? See, in both cases it's going to infinity. X may be negative, but f of x is positive, right?
Yes, sir.
Okay, then tell me what will be, I'll choose for all m greater than 0. What will have to do?
Sir, x less than 0.
I will have to find delta such that for all x minus delta to 0, x belongs to minus delta to 0, what holds? Fx will be greater than m, right?
Yes, sir.
So this is giving you the left hand limit from minus delta to 0. This is the left hand limit, and this is giving you the condition for the limit is going to infinity. I hope this is clear. Similarly, 1 by x, this is for x less than 0. Oh, sorry, Hedvi. I'm very sorry. You meant this x, this condition is x less than 0, right? I think you meant that. You meant x less than 0 condition. For x less than 0, you are doing this. That is true. That is correct.
Okay, sir.
Yeah, because we have taken x greater than 0 one condition, x less than 0 one condition. That is true. That is absolutely correct. So x would be greater than minus 1 by root m, right? Because I'm going to take my minus condition. So if x square is equal to 1 by m, x is plus minus root m, right? Plus condition will only go here, minus condition will only go here. So I can also choose delta is equal to 1 by root m. So LHL is equal to RHL is equal to 0. I hope this is clear. Similarly, some of you have, let's see how if limit is minus infinity, what will we do? And then we'll go to algebraic methods. Limits equal to minus infinity. How will I formalize? Say at C. Say this is C. On the left hand side, my function is going to minus infinity. Can anyone think of this function? A function like this?
Sir, log x function, no?
Correct.
I think log x.
Log x function, but you have to tell me how will I convert log x. So that will help you.
Sir, log mod x, I think.
No. So this is my x axis, this is your y axis. This is your 0 and this is your minus c. So log x function is this, right? Correct?
Yes, sir, correct.
I want to shift this function. So how will I shift? This is just practice of previous sessions. To minus c, I want to shift it. So how will I shift it to minus c?
Minus x plus c.
Minus.
So this function, see, there's an issue here, I'll tell you why. And then we'll take across the y-axis. So which should we do? Okay, instead of doing this, let's shift this to c. Why not shift this to c and then take a, how to shift it to c? This is log of x minus
C.
Right? Now how will I convert it to minus c?
Sir, shifting of origin
X
x
minus
c, like.
X minus c.
So f of, what did I say? F of x, if I replace by f of minus x, what will happen? Your reflection will be across your y-axis. Why, you see, I'll show you, I'll give you the reason also. So if I write, so this is your minus c. So what will be the function now? Just think that this is true for a particular time, moment of time. So this is your log of minus of x minus c. So this is your log of c minus x, right? Correct?
Yes, sir, correct.
Yes, sir, correct.
C or c plus x, right? So I don't, oh, minus, yeah, correct, very good. So at x is equal to minus c, you are going to infinity. So why does this happen? So for values x greater than minus c, you see c minus, say, 0. What will it be? Say you have,
Sir, at which value?
between values, say you have x minus c, right? So if I put a value of x equal to, just one second, x is equal to c, if I put, in this case, it is going to 0.
Yes, sir, log 0, 0, no?
No, log 0 is minus infinity, na? Log, just one second, x minus c, just one second. So this is your x minus c, and it is not defined for x values less than that. So I think this function is defined for values of less than c, less than c. So this is, I think I made a mistake here. It should be minus c minus x, most probably. I don't know what mistake I made. Let's just see, wait. If it is minus c minus x, then this makes sense. Yes, this is minus c minus x. Why is it not coming this way? So why, okay, x minus...
Sir, c should be positive. C should be a positive number.
Oh yeah, so c is a... So here I took c as a positive number. So this should be minus c. Correct. So I think I took c to be a case of a problem, I think. Let's see, wait. C was positive only, so c was positive, so I went to this, right? So this became your function, x minus c. This is correct. For all values of x going to c, it will be 0, and going to infinity, it is this. This is your log of x minus c. Oh, if I do that, it will be translation across this. Nah, I'm wrong. I'm very wrong. See, what is your new x-axis and y-axis? I'll just, doubt will be cleared. What is your new x-axis and y-axis? I'll erase this just to avoid confusion. This is your y, this is your y, this is your x, right? If I write x is equal to c here, this is your new y-axis, right?
Sir, better put x dash and y dash for the new axis.
Exactly, I will put that only. So x dash is same, so I will put y dash, right? So you will take f of x as log of x minus c, right? See, I'll do it again stepwise, just for you to understand. And you stop me at every step you don't understand. You can always put values and validate your algorithm is working correctly or not. See, step 1 is, this is clear, right? This is 1. This is your log x. Okay. Once I do one step, you just someone tell me yes or no, and then we'll go to the next step. Right? This is your y-axis. This is your x-axis. This is 0, 0. Yx. Similarly, this is your c, you say. So c, this is your y dash. This is log of x minus c. Do you agree or not agree?
Yes, sir.
So this is your new, this function we have all agreed in the previous round of discussion. So this is your y-axis, this is your x-axis. So this should be your reflecting axis, right? You can only reflect across the current axis. So if I'm taking a negative sign of the entire thing, right? So I'm taking a negative of the, what am I taking? I can do two things here. I did a mistake. Say f of x minus c is this, right? This is one thing. I can write f of x minus c, I can write is this way. One thing is this. The second thing I can do is I can write g of x as this, right? This is one way, this is second way. Now I will ask you, if I do g of minus x, which y-axis would you use to reflect?
Y does.
G of x, g of minus x if I do. What is g of minus x? I think you will get this. So let us do f of x minus c ka minus, okay? So this I will do minus, say, minus of f of minus x. Is it okay? The whole argument is getting a minus. Is that all right? Say I'll name this as y dash, okay, is equal to log of y dash, right? Is this nomenclature correct, or are you understanding? See, I will name log of x minus, I will name y x minus c as y dash, or say for our sake x dash. This is okay? So I can write f of x dash is equal to ln of x dash, right? This is one definition, right? For x dash, which is the y-axis? Which is the y-axis?
Sir, for x dash it should be y dash. No?
Correct. For x dash is y dash, because I'm reflecting. If I do f of x minus, so what it will become? F of, so I will be using this as the reflection.
C minus x it will become.
This will become minus of x minus c. It will become f of, this is where I was making a mistake. I made a silly mistake by putting argument ka negative. So but I was telling I will put g is negative. Now is the function g of x is equal to log of x minus c, right? Did you understand? Now if I put g of minus x, now which one will you use to reflect? Now you will use this axis.
Y-axis.
Correct.
Sir, it should be c minus x, no? Log c minus x is equal to g of x.
I have written g of x as log of x minus c, right?
Yes.
Correct. Yes, sir.
So I am writing g of minus x. What will it be? Log of, I wrote the definition correctly, but I wrote the definition. I will put minus x in the value of x. That's it. Right?
Okay, understood, sir.
So this becomes log of x plus c is negative. X plus c, log of x plus c is this. Everybody agrees? So this is also shifting, and log of x plus c negative is this. So this is how we will, this is just a recap. All the possible rotations and reflections I did. If there any doubt, you tell me, or I'll go to the problem statement. Go.
Sir, it is correct, sir.
Yeah, I know, it is correct. I, as soon as I got the mistake, I saw just a value replacement error that we did. It was all our steps were actually correct, isn't it? Let's see. So let's see a minus m that we take here, right? Or yeah. Now, how will I define this? So tell me, someone tell me. So for all values of m greater than 0, there exists a delta greater than 0 such that f of x minus L, no L here, f of x is less than minus m. Did you understand? This is your minus m. So if I give you minus m, I will always be able to find a delta if it is diverging such that this is between c minus delta to c. This is what is the definition of this? Limit x tends to c minus f of x is equal to infinity. Did you understand? Or minus infinity, sorry.
Sir, we also do this in epsilon also. M represent epsilon, like epsilon delta method.
Exactly.
Same, no?
Epsilon delta method, what happens is there's a limit, right? So there's a limit between which the function fluctuates. So you can tell that between L plus epsilon, L minus epsilon, f of this will be. But here there is no limit, na?
Yeah.
So here this function will always be, f of x will always be greater than minus m for all values of delta, for all values of x between this range, right? There's no limit, there's no epsilon that you can find. So this is how you define. This is how you put everything together. So in my notes you have all the definitions and I've explained all of them together properly and solved questions. I think you will be able to do it now. Okay. Now let's do some fun questions. 4 or 5 fun questions we have. We'll then stop. All these will be algebraic questions that we generally be asked in exams and all. Let's do it. So let's do question 5 here. It's a small question. So how do I do it? N tends to infinity, summation of 2 to the power minus I, right? I equal to 1 to n. Similarly, limit n tends to infinity, I equal to 1 to n, 3 to the power minus I. Okay? Or we can say 1 by 2 to the power I, 1 by 2 to the power 1 by 3 to the power I, from 0 to infinity. Any doubt? How I wrote 5 as this equation, question 5. How I expressed it as a sum? I hope there is no doubt, right? Is there any doubt?
No, sir.
No, sir, it is fine.
So what now? All of you said it is fine. Tell me what will be the numerator sum. So I am using basic algebraic method techniques. These are all well-known class 11-12 methods. When you have limit of a fraction, you can take limits on the numerator and denominator. I have also spoken about this in my previous sessions regarding the p by q also can be written as epsilon delta. You can see the lectures of professor also. But these are all same. These are all algebraic methods follow in limits, so you can use them and you can try to prove some of them by yourself to check that whether you have understood epsilon delta. Anyways, some tell me what is the numerator sum?
1 minus 1 by 2.
Sir, no?
Yes, it's a GP. So GP is summation of a to the power
GP
of
series.
gp to the minus gp to the power r tends to 0 to infinity is equal to 1 by 1 minus a if a is less than 0, right? This is the gp formula I am using. So the denominator becomes 3 by 2 and the numerator becomes 2 by 1, so it's 4 by 3. I hope there is no doubt regarding this question. So 5 is solved. Let's do 6. Now 6, someone of you tell me how to do it. Go
sir,
ahead.
in question 5, sir, can you write some few more terms, like to get the limit? How will the limit will expansion of this limit?
Limit which expansion?
Sir, this numerator and the denominator,
Huh?
expansion of the limit.
So that's what I told na, limit p by q is nothing but limit p by limit q. This always holds if limit p and limit q are finite. Okay.
Sir, but here they are infinite, no?
How are they infinite?
N approaches infinity.
So the numerator sum is also finite, right? So 1 by 2 plus 1 by 2, that is 3.
Okay.
That
Sum
two.
is finite.
Yeah.
Sum is finite. Number of terms will be infinite.
Terms does not matter, not. You want your p to be finite, your sum, your numerator to be finite.
Yes, sir, correct.
That's it. So let's do the next question. Question 6. We have already done this in the previous session, so you can go back and see the videos. In the lecture session also it was taught. But this is standard stuff. You can get in any +2. But the question how to solve, I'll just do a few, because this is what will be asked in your question paper, as far as I see the assignments and all. It's not possible to ask questions regarding epsilon delta in a of online or objective exam. So how will you do this?
Sir, there will be subjective question also in the examination.
So okay, then also you will not be asked. Also, I saw the assignments and also not that difficult. But anyways, when you are told to find limits, you will be doing it algebraically only. Nobody does it using epsilon delta. Epsilon delta is just to understand how whether limits converges or not. To whether they.
Yes, sir. Yes,
Yes.
sir. Correct.
So how will we do this? This one. Any ideas?
Rationalize it.
You mean by dividing by x square, right?
No,
sir,
sir. We can find it.
The
factorize.
factorize.
Oh, okay. Then it is good.
Yes, sir,
Then you're right. So I will take denominator as x square plus 5x minus 14. That is what I was asking. That's good that you answered. Limit x tends to 0, x minus 2 square by x plus 7, x minus 2, right?
Yes, sir. Expression x minus 2.
Yes, because it is 7 minus 2. This is the middle term. So x minus 2 is cancelled as you are not taking limits as 2. Now you see x minus 2 by x into x plus 7. So both at 0 plus and 0 minus, this is going to infinity, right? 2 by 7 by x, right? Minus 2 by 7 by x. So does limit exist? Say at 0 plus, limit x tends to 0 plus, what is the value? And say limit x tends to 0 minus.
Sir, it is infinity by infinity form, no?
Is it? So denominator is a square, right? So it's a smaller number than the numerator. So I'll show you why. So you
Sir, dividing numerator and denominator by x.
you can divide it, no problem. But still in the denominator you will get x plus 7. In the numerator you'll get 1 minus 2 by x, right? If you divide by x,
Yes, sir. In numerator 1 minus 2 by x, denominator 1 plus 7 by x.
1 plus 7, x plus 7, because there is one more x extra.
Okay, correct. Got it.
That's why it's not working.
Huh.
So plus limit tends to x0 plus is minus 2 by 7 by 0 minus 0 plus. So it's minus infinity. On this it is minus 2 by 7 0 minus, that is positive infinity. So limit does not exist. Understood?
Minus infinity or something.
One is plus infinity, one is minus infinity. If both were infinity, I would have said limit is infinity as we discussed.
Okay.
But here we are seeing one is infinity and one is minus infinity. So limit does not exist. It is clear. Why can you tell me? You see, the numerator is a quadratic, and the denominator is a cubic equation. So cubics are smaller than quadratic.
Cubic are smaller than quadratic, so denominator is lesser.
For x tends to 0, it will be smaller. So denominator will be lesser. Generally, not speaking always, but here it's definitely turning out to be true. Question 7.
Sir, I have a doubt.
Huh.
Can you explain why it is plus infinity for x tends to 0 minus?
0 minus, what is the denominator?
0 minus.
0 minus is a number less than 0 or greater than 0?
Less than 0.
And the numerator is also less than 0, right?
Yes, sir.
So if you divide a number, the two numbers that are less than 0, what do you get?
Oh, plus infinity, yes.
So
Thank
it's
you,
a
sir.
positive number. No problem. You can always ask. So let's do question 7. So it's 7 is, it's one of your questions in the assignment as I remember. So I'll just copy this. Copy. Paste. This is question 8, right? Or 7? 7. So any ideas how will I do it? It's a 0 by 0 form. Are you agreeing to it?
Yes, sir.
Cos 0 is 0. Is 1.
Yes, sir.
1 minus cos 0
form.
is 0. X is 0. So determinate indeterminate form, we can, limit may exist, may not exist, whatever, anything can happen, right?
Yes, sir. L'Hospital rule.
No, we will not use L'Hospital rule here. We can only use, see, in this session we have used sin x by x. You have seen this week's video, right? X tends to 0 as 1. We have proved this.
Multiply and divide by 1 minus cos x.
Very good. We have seen this. This limit we have proved using this circle method. You can use this circle method, and for a particular value of theta, you can use this area of the circle, this area of this two triangle, these three things you can use, and this circle area also you can use to get the equation that you require. This proof you can use using the sandwich theorem. This is done in week 3 in the lesson, this course. You can go back and see. Doing the same thing does not make sense. Let's go ahead. So limit x tends to 0. So as who pointed out? Your name, please.
Hedvi.
Yeah, Hedvi will do this. Why do I do this? Any reason? Just to get a 0 by 0 of the form in sin x, right? So now I get a sin x 0 by 0 form and cos x also 0 by 0 form. See. So this is, so limit pq is also limit p into limit q. Let's assume.
Yeah. Yes.
So this becomes 1. Generalization, yes, correct. So limit x tends to 0. Do anyone remember this class 11 formula? What is 1 minus cos x?
2 cos square x by 2.
2 sin square x by 2.
Acha, sin.
Plus is cos square x by 2. So now you see you have a good form, right? Limit x tends to 0, sine x by 2 by x by 2 into sine x by 2, right? Understood? From here to here, I just wrote sine square x is sine x by 2 into sine x by 2. That's it. And divided the denominator by 2. So this is 1. So what will be the limit? This will be 0. Limit is 0.
Sir, previous page, sir, last slide, the solution.
Yes.
हाँ ठीक है सर.
Good. For this one, what will we do? At x tends to 1, we'll do something like this. Can anyone tell me what to do? This is a bit complicated question.
Divide everything by x minus 1.
Very good. Absolutely correct. How did you understand? Other than practice, what is the idea that you will use?
Generalize sine fx by fx method.
Correct. Absolutely correct. I was going to exactly say this same sine x by x method you will do.
Sir, what is this generalized sine fx?
There is nothing, no rule. So if you have fx giving you 0 and you have sine fx, so that is also sine x by x 0, right? So if I have sine of fx by sine x by fx as limit fx tends to 0, this is also 1, right? That's what he's saying.
Yeah.
That's,
Yeah, this is right.
there's just a name he's telling. So how will I middle term the top numerator? This x minus 2 into x minus 1, right? Minus 2 minus 1 is minus 3. Yes, 2 into 1 is this. X minus 1 into x plus sine of x minus 1. Any doubt of this factorization?
No, sir.
Great. So let's divide as Mr. Pandey had suggested by x minus 1. So we will get x minus 2 by x plus sine of x minus 1 by x minus 1. So the numerator you see is a finite limit. So we can do numerator, and so is the denominator. This won't be generally 1. So let's assume that they are finite and let's do it. X minus 2 limit x tends to 1 x plus limit x tends to 1 x minus 1 by x minus 1 sine. So this is your 1, this is your 1, and this is your minus 1. Any doubt? This is minus 1 by 2.
Sir, in case of sine x minus 1, our limits should change from x equal 1 to x minus 1.
X equal to 1? I didn't understand. So limit.
No, because that limit is defined for sine x by x.
So this is your sine of x minus 1 by sine x minus 1. For x tends to 1, right? So this is limit x tends to x minus 1 tends to 0, sine of x minus 1 by x minus 1. Understood?
Yeah.
This is the idea.
Okay.
So if it's something is tending to something, yeah, that x minus something tends to 0, right?
Correct, got it.
That's the idea. Next few questions are very simple. I will tell you to do one of these as a homework. Say, do this as a homework. How will you do it? Let's do it here only. No need of doing homework. How will I do it?
Rationalize it.
No, divide by 0 x. Whenever you have infinity, try to divide by x and remove all the terms, because 1 by any constant by infinity is 0, right? You can do away with this term. So I think you meant rationalize. By rationalizing means you meant removing the square root in the down. No, you don't need to remove the square root. You can do it, but it does not. It's not required. So it's 4 plus 1 by x square. If you have doubt, you ask me. So this goes to 0. This goes to 0. So it's half. So you tell me which step do you have a doubt in? or I can do it once again. I divided by x, right? Let's do it. People may have a doubt. Question 9. Limit x tends to 0 or infinity x by 4x square plus 1 minus x or 1, right? Yes, let's do it. Tell me. So limit x tends to infinity, the trick is divide by x. 4x square plus 1 by x minus 1 by x. This is equal to 1 by limit x tends to infinity root over of 4x square by x square plus 1 minus 1 by x. Any doubt till now?
No, sir.
So 1 by is just algebra. Limit x tends to infinity root over of 4 plus 1 by x square minus 1 by x. So this will go to 0, this will go to 0. So you will have 1 by root 4. It's equal to half. Okay?
Sir,
Yeah.
so in the third step, when you wrote it as 1 divided by limit of x tending to infinity, there you wrote it as in the denominator you wrote x square. How do you think?
I took the root. Took x is inside the root.
Achha, okay.
This is not in the root, na?
Yes.
Just took it inside the root, just to cancel and stuff.
Okay.
So last.
Sir, limit cos x by x when x approaches 0 या infinity क्या होता है?
I can have to check
limit.
that. Cos x by x.
हाँ, when
At
x
infinity is
approaches
0, na? Infinity it is 0. Clear. This is between minus 1 and 1. And this is always, if you divide a finite number by infinity, it is infinity, right? Limit x tends to infinity. This is 0.
Sandwich theorem.
Sandwich theorem you can use between, so it's between minus 1 by x cos x between x. Okay,
हाँ sir.
that's it. So answer is half.
So 1 second. Thank you, sir.
Okay. And at 0, if you take the derivative, you see it's 0, right? So sin x by 1. But it's anyway 0, na? Yes, cos x is at 0, it is cos 0, it's infinity. Cos 0 is 1, 1 by 0 is infinity.
Yes sir.
Is it minus sin x? Just one second. Yeah, it's not even a 0 by 0 form. It's not a defined limit only. It's infinity. Or a limit does not exist actually. Cos x by x at 0 plus it is positive infinity. At 0 minus it is minus infinity, right? Because cos x is an even function. At x 0 minus and 0 plus they are both same, equal to 1. Right?
Sir, the last line what you said?
See.
हाँ, cos x is an even function because cos of minus x.
Yes, so 0 minus, at 0 minus cos of 1 by 0 minus is minus infinity, right? 1 by 0 minus is minus infinity, right?
Okay, yes, when x approaches 0 minus.
Yes, so it's less than 0, so it's minus infinity. 0 plus is positive infinity. So last question is this. This will be useful for many of the applications that you do. That's why I kept it. So fx and gx are both 0. You are told to find limit x tends to 0. 1 plus fx. Limit question 10. 1 plus fx by 1 by gx. See the intuition behind this. Limit x tends to 0, fx is 0. Limit x tends to 0, gx is 0. So it's of the form 1 plus 0 to the power infinity, right? What is 1 to the power infinity is 1, right?
Yes.
Correct. But if you have a very small number, Ravi is, but if you have a very small number and you multiply and you take an exponent with another number which is very small, very large, you may get an infinite digit. It is also an indeterminate form. That's what I mean, right? Hello?
Yes, sir.
So this is also an indeterminate form because you have a small perturbation above 1. If fx is less than 0, it can go to 0. If it is minus 0, then it can, at infinity, it can go to 0. If it is a little bit 0 plus, it can go to infinity, right? It depends upon the dynamics of these two functions is what I mean, right?
Yes, sir.
So how will you do it? Whenever there is this power form, you take log on both sides. This is the trick. Assuming the limit exists. Assume limit exists. Okay. If your limit exists only, then only this will hold. Otherwise it does not hold. Log L. If limit does not exist, then you cannot take log, of course. So, what is this? Log of 1 plus fx by gx, right? I would ask you to ask questions to me. Is this step clear? Taking log. I hope it is clear. Go ahead.
Sir, this 1 by g of x would come out of limit, or it?
Why will it come out of limit? It will be inside. I have taken log inside, right? Log I have taken inside the limit. So it should be like this. So I have written it this.
Yes, sir. Yes, sir, correct.
So we all know this formula, log of 1 plus x by x is, you can prove this using sandwich theorem and your epsilon-0 method. What is it?
ln1 plus x minus ln x.
By x. So what is the limit at x tends to 0? It's 1, right? You forgot this. Well, log of 1 plus x by x is 1.
1.
Yes, these are all, you can also prove it using the sandwich theorem, epsilon-0. You can prove epsilon-0 and prove it. It is not that complicated. Epsilon-delta method. Anyways, so what will I do? Tell me. Somebody had an idea. Like Mr. Pandit told that we could generalize these. So anyone else, can you tell me how to generalize this? So that I can get a 1 out of this log 1 plus x function.
Multiply, divide by.
Multiply, divide by fx. That's it. Very good. X tends to 0, limit log of 1 plus fx by fx into limit x tends to 0 fx by gx. Step clear?
Yes, sir.
So this is 1. As both fx and these two goes to 1 at x tends to 0, I have already goes to 0 as I have defined here. So your fx is also going to 0 at x tends to 0. And so you have log of L is equal to limit x tends to 0 fx by gx. So you can use this form directly. Limit x tends to 0 fx by gx. Right? If you can have this 1 plus 0 to the power infinity form, you can use this directly, right? E to the power. This is e to the power limit x tends to 0 fx by gx. So that this division always stays in the division and this stays in the numerator. So depending upon this dynamics, it will tell you if it is going to diverge, converge. E to the power will tell you the answer. Okay, that's it for today. We are shooted over time. So if anybody has any doubt regarding today's session, you can ask me, or we'll start with session week 4, continuity and all, and slowly move into derivatives from the next week 4, next week.
Sir, these notes are available. In the portal.
Yeah, in the YouTube. YouTube, though, I think you all have access to my YouTube, right?
Yes, sir. Through portal, I think I will check.
No, but I have shared my YouTube. You can just subscribe to this YouTube channel for the next 3 months. This is where the NPTEL wants us to upload the video. So it's a NPTEL channel. You can just subscribe this, and you will just get the videos. It's streaming presently only. So if you can also do that, you can see my video also there. So it's in this offline, this Gmeet, the video is not available. So there I have.
Yes, sir. I got, sir. It is live there.
Yeah. So no problem. So there in the description box, I have the link to the folder. Hopefully I'll update these in that folder. So every week notes are available there. Okay. Great. Thank you for your attention. I hope more.
Sir,
yeah.
Sir, in the next class, which topic we'll discuss?
I think it's continuity. Week 4 of this lesson. Continuity and all. We'll do continuity and all. This is week 4. Week 5 onwards, I think differentiability and all these things will be there. I hope next class onwards more people join. There were 15 the first class. Anyways, I try to make it as interactive, as intuitive as possible. It's good that more people join. Anyways, okay.
Okay, sir. Okay. Thank you, sir.
Okay. Thank you. No more questions, I suppose. Thank you.
Thank you.
Thank you, sir.
See you next week.
Thank you, sir.
Yeah.
Thank you, sir.